Alright, so I'll be talking about an AI code generation agent. So right now this name is very vague, but as I get deeper into the project, you guys will understand a bit more of what I'm talking about. So I'm gonna give a brief introduction about me. Like how Shoku said, my name is Clement Wang. I'm currently a freshman at Westlake Academy. I have 2 years in FLLC and 1 year in FTC. This is going to be my second year. And I'm currently part of 8565 software's team, and I enjoy chess and piano. So I'm going to give you guys a brief project background before I dive into the issue and how my solution and how I try to solve it. So a lot of you may already be familiar with configuring your robot. And for those who aren't, it's essentially setting up your hardware components, such as your motors, sensors, servos, inside the robot software. So there's two main parts of this. The first part is assigning the components names, types, and ports inside the driver station. And the second part is matching the components names and type in your op mode. So something neat about this that not a lot of people know is once you create a configuration on your driver station, this is automatically saved as an XML file, as the one on the right, inside your driver station storage. And this configuration file can be located under the SD card /first folder, which I'll go more over in a bit about how to pull it. But I just want to talk about how it's a good practice to save this to GitHub, because this could allow you to share it not only across driver stations, but use it as a backup in case one of yours gets wiped. So to start your configuration, we're going to be using something called ADB or ADB polling to be more specific. So ADB stands for Android Debug Bridge, and it's a command line that allows you to communicate with devices. So more specific, I'll be talking about ADB polling, which is a way you could copy files from a remote location to a local one. And here's just the syntax, which you can type in your terminal once you connect it to your driver station. So the main issue that I noticed is that initializing all of your hardware components in your outload could be a time-consuming process. At the start, if you only have a couple of motors and a couple of sensors, this can take a short amount of time. But once your robot grows in size and your team develops more, you're going to add more sensors, more servos, more motors. And this can take a long time and it's prone to errors, such as you might mismatch the type and you might mismatch the name. And this leads me to my solution. This is an AI-generated initialization. So my goal was to design and create an AI assistant that is capable of generating AI for initialization code for FTC robots using the XML file of the robot configuration. Main objective that I had for this is I hope that the generation can be neat and accurate while creating a prototype of a responsive UI with syntax highlighting. So I'm going to dive into the process of my agent creation now. So as a quick design overview, I want to highlight the main parts that I'm going to be talking about and the main parts that make up this project. So the first part would be the XML file opener. We need to obtain the XML file from our driver station, and we need to open it and parse it so that AI can understand it once it's put in. And next, we use an AI service requester using a redefined prompt. So what this means is I'm going to use an AI service, and I'm going to use it to obtain the initialization code based on my XML file. And next, I have the user interface in the application. I want to develop this so it's a prototype, but it's good enough to show what I want, such as its functionality. And lastly, a syntax highlighter, which is where it's a visual outline that makes your code look more neat. So first was the XML file opener. So with Python's built-in reading and writing of files, it's made it a lot easier. I used a with statement, which replaces the use of a try and find. So for those guys who don't know what a with statement is, essentially it allows me to open and close files automatically, and this can help prevent data leaks and automatically manage resources. And after the XML files return, I use a neat function that allows it to remove all irrelevant information. So as you can see at the top image there's a lot of information that you don't need in your robot's initialization. This could be the ports, the serial numbers, etc. But in the XML file below, you can see that all of that irrelevant information is removed. You only have the type and the device name. And so allows the AI to understand it a lot easier. Next part is the AI service requester. So I use an API key to request to Grok's API to obtain and retrieve information. And two main prompts were given to this AI. The first one was a context and clarity prompt, and the second one is user input. Essentially the context and clarity input, this is where I tell the AI what I want it to do and give it a brief background information so it can return more accurate results. And the user input would be the XML file that I took from the robot's configuration. And the context prompt was generated through a process called prompt engineering. So prompt engineering is a process where you essentially tune your prompt in a generative AI so you generate desired outputs. And how can you do this? So first you can provide relevant background information. This can be things such as the FTC SDK, op modes, Java documentation, syntax, all of that stuff. That allows the AI to write more clear code and to more understand the situation. So next would be to modify inputs. So like I showed before with the XML files, I removed relevant information, that way the AI can understand it much easier. And another good technique to use is filtering tokens. So tokens are essentially the characters that you have, and the AI takes in all those characters to determine a result. And by filtering these tokens, I could modify what the results I wanted. And two ways you could do it would be temperature and whitelisting, which I use in my code. So adjusting the temperature would be adjusting how creative it is. More creativity in AI means more unique results. The follow-up of that is there's less standardization and it causes more errors to happen. So for this project, I used a relatively low temperature. Next is whitelisting. Whitelisting is where you only allow a select group of tokens through. And I use this method so I can hone down to those style that I wanted it to output as. The next part that I did was I developed my user interface and application. So this application was created using Technicbots, which is a basic Python library that allowed me to quickly develop a prototype that I can show you guys today. So, like I said, it's a simple library with minimal setup, and it's quick to start in prototyping, as you can see on the right there. It has active layout management, so I can control where everything goes, and it's extendable with third-party libraries, which I'll talk about in a moment. So, a brief second overview of what's going on. First, we have our web control hub and the folder with the XML stored aside. By using an ADB pull command, we retrieve the XML file and put it into my code generation AI. Through that, the XML content is parsed and put into the main AI, where the LLM understands it and returns it to its best extent with the prompt engineering in mind. With the Java code returned, I could then syntax highlight it and put it on the UI. So about the syntax highlight I was talking about earlier. So essentially, it just allows the code to have color, and it's a great visual appeal. So the main process for this is after I take my generated Java code, I use a lexer, which tokenizes the Java code. This breaks it up so a Python library called Python can understand it, and it can effectively highlight it, turning it into an HTML code. I then apply my own settings and I receive the HTML file, which is highlighted. And once going through visual cleanup, such as color modification and indentation, I have a clean and highlighted HTML. So here's a quick demo of it, where essentially I select a file and I open the robot configuration. And once I do, you can see on the left side, you have your generated init code. And on the right side, you have your XML. And what you can do is you could directly copy the output, or you could just review it. And then this AI works well with longer files as well. So here I select a much longer XML file. It takes a bit longer, but effectively the results are the same. I generate a consistent AI code with comments, and it highlights every section to be easy to understand. So here are my conclusions over this project so far. Some pros is it saves tons of time when you have a larger robot. It has a simple to understand UI and it returns a standardized format. So no matter what type of XML you put into it, say you modify yourself a bit, it'll still return the same Java code format. The only con of it is because it uses an AI, it sometimes makes mistakes. Now some future improvements I could do. So first, I'd say UI is a big thing. Currently, it's only run locally inside a Python file, and I could expand that to adding it to a website or create a full application. Next would be a good idea to integrate it with other tools. So Android Studio, a popular platform to develop your code on, allows you to create plugins, which I could easily create a plugin for and use the AI to generate the initialization code all inside of Android Studio. Next is something called the XML schema validation. So this ensures that all the XML files put in are the same format. And this can allow for more consistent generations, and also functions can modify it so it would fit that standardized format. If I were to set up automation and continuous integration, this would mean this application could continue to develop on its own while following new FTC trends. And upgrading to a better LLM or large language model would allow my AI to work much faster and give you better results. And lastly, of course, with the AI, I could generate more code and use compiler verification. So not only can this AI have potential to generate initialization, it has potential to generate maybe some of Telia, maybe some autonomous, and maybe some of both. And with compiler verification, you can ensure that all the code is accurate. So do you guys have any questions? And thank you guys for listening.
All right.